All right, we are live. It looks like, yeah. All right, we're live. All right, yeah. So basically, next Monday, I have an Amazon interview, like a super day type of interview, and so we'll just be like practicing the Leetcode questions here. The top Amazon questions. So yeah, I'm just gonna like live stream it and talk through it to simulate being on an interview. Yeah, so there's this thing here on Leetcode, top Amazon questions. Interview style, test size, conduct a simulation. From the list will give you a preliminary grasp of Amazon's interview style and test size and conduct simulation. Okay, so theoretically, these should be like good practice. Fuck, a lot of medium and hard ones. Yeesh. Let's just fucking get going, I guess. All right. Yeah, and I also heard that solving them in C++ is a good thing to do. Like they don't really like Python for some reason because I guess you got like a lot of stuff is abstracted away. So yeah, let's get her going. Let's get her going. All right, make array 0 by subtracting equal amounts. You're given a non-negative integer array, nums. In one operation, you must choose a positive integer x such that x is less than or equal to the smallest non-zero element. Subtract x from every positive element in nums. Return the minimum number of operations to make every element in nums equal to 0. Minimum. Okay, so let's look at the examples here. So you got 15035. Output is 3 because first operation you choose x is 1, right? And then you subtract 1 from everything. So that'd be 04024, 04024. Yep. And yeah, x from every positive. Okay, so yeah, 0 just stays the same. Okay, then you look at the next smallest, which I guess would be 2. X equals 2. 2, 2, 2. Yep. And third operation. Okay, return the minimum. All right, yeah. So so basically, you just need to find I guess find the largest element in the array, and then I guess keep counting up until yeah, well, okay, well, I guess one way you could solve it is, I mean, it all depends on the largest element in the array. So right here, you scan through the array, you see 5 is the largest. So now you just need to go like 5 minus the smallest number here, which would be 1. So that's 4. And then this new updated array, you now do 4 minus 2. All right. Yeah. Let's just, I guess I'll just kind of brute force it and then see if that works. No, I have a better idea. So we'll keep the amount to subtract. So, right. So let's say here, the amount to subtract is 0, right? Then on the first operation, because ultimately what you want to do is the amount that you have subtracted up until that point needs to be greater than or equal to the largest element. Okay, so let's say amount to subtract is 0, right? First element, first you scan through here, you see 5 as your largest. Okay. In the first operation, choose, yeah, so x equals 1, right? Because you scan through and you see 1 as the smallest. So then the amount to subtract is 1. Okay. Then you scan through it again. And for each element here, you do the element minus the amount to subtract. So this would be 0, 4, -1, 2, 4. But if the number is less than or equal to 0 or less than 1, then you just disregard it, right? So it'd be disregarded 4, disregarded 2, 4, and then you see 2 is a thing. 2 is your new smallest. You add that, so now it's 3. The amount to subtract is 3. You do the same thing. Disregard 2, disregard 2. Okay. Then you see 2 is the biggest thing. You just do 2. And then I guess that's the largest number. And then you return 3 because that's how many iterations you did through this. Okay. Let's code this up. So I guess and largest 0. I just realized I wasn't sharing the right tab. Oh well, so good thing no one watches these. For and I equals 0, I is less than n, and n equals nums dot length. Pretty sure this is how you get the length of a vector. I is less than n, I plus. Okay. So this is to get the largest, right? This is also do and num operations equals 0. Then down here, we'll just return num operations. Bang. Okay. So this is just to get the largest number. If nums at I is greater than largest, I keep forgetting this isn't Python, C++ syntax, then largest equals nums at I. Okay, so this just gets the largest. Okay, now I can, I guess, do a while loop. while keep going through this until largest is okay. Well, largest is greater than and number to subtract equals 0. Well, that is greater than number to subtract. What do I want to do first here? Well, I guess the last thing I want to do is num operations plus, right? I want to add 1 to the number of operations. Just so I don't forget how to do that. Okay, then you want to find the smallest number in this array, but you want to do it based on your number to subtract. So find smallest number in array, and smallest positive number based on number to subtract. Cool. Okay, so we're just going to loop through it, and I equals 0, I is less than n, I plus. Okay. So if and smallest current smallest equals 0. If nums at I minus number to subtract I guess first, if minus number to subtract is less than or equal to 0, we just want to continue, right? We don't even want to worry about this. I'm going to just do this here. New number equals this. New num, I continue. Else if new num or current smallest, I'll set that equal to the largest. Largest, right? Because it's got to start as big as possible. Largest is that. Find the largest here. Okay, so it's equal to the largest, right? Initialize to the largest. Then if new num is less than cur smallest, new num is less than it, then you set the cur smallest equal to new num, to your current number, right? Okay, so then this finds cur smallest. Okay, then what you want to do is do number to subtract. You want to add cur smallest to it, right? This is now the number that you want to subtract. And once it gets too big, you plus it. You know, let's just see if this works. Let's see if it compiles first. I doubt it will. Yep. Length. Okay. Let me just Google how to get length of a vector in C++. Dot size. That's what it is. Yep. Too much Python. Too much Python. Bang, bang, bang. Okay, so pass the first two. Does it pass all of them? Let's see. It does. Hey, and it's pretty freaking good runtime. What memory? Huh, good memory too. We're so back. We're so back. Chat, I think we're back. Oh, they used a map. It's whack. Fade all that. Maybe I'll come back here and try to sell me with a map, but it's just iterating over it multiple times works. Well, wait, no, how would you do it with a map? No, it's not size under map. For an item. Let's just use, I don't know. This is more verbose. All right, cool. All right, thank you. Next. Copy list with random pointers. Ooh, this one doesn't look very fun. It looks like in Python. I bet you it looks way better in Python. Yep. Yepers. All right, next question. A linked list. Okay, I love linked lists. I fucking love linked lists. A linked list of length n is given such that each node contains an additional random pointer which could point to any node in the list or null. Construct a deep copy of the list. The deep copy should consist of what's node value equals val, next equals null, random equals null. What is a deep copy? Alternative is a deep copy, meaning that fields are dereferenced rather than referenced to object being copied. New copy of objects are created for any referenced object. Deep copy in progress. What? Let's keep going. It should consist of exactly n brand new nodes, where each node has its value set to the value of its corresponding original node. But the next there are two nodes x and y in the original list, where x dot random points to y. Then for the corresponding nodes x and y in the copy list, x dot random points to new y. Okay, I see. turn the head of the copy of the linked list. The linked list is represented in the input-output field. Input-output as a list of n nodes. Each node is represented as a val random index. The linked list is represented in input-output as a list of n nodes. Node.val. Random index, the index of the node range from 0 to n minus 1, where the random pointer points to, or null if it does not point to any node. Okay, so the dbcopy list, dbcopy check is actually exactly n brand new nodes, where each new node has its value set to the value of its corresponding original, or each new node is set to the corresponding original. Both the next and random pointer of the new nodes should point to new nodes in the copy list. There's a pointer in the original list. I see. Okay. So given this head, right? Okay. See. Okay. So now I need to relearn how to do like new and shit like that. C++, how to construct a class. Okay, how do you create my class? Okay, here we go. So just go node new head. Nice. Node new head. So I want to see what happens here. No, it's gonna. Okay, class node. Right. Next and random. So when you initialize it, you need a value. This value is value. Next is set to null. Random set to null. Okay. Okay. This should take the thing of head dot val. Okay. See if this compiles. This pointer didn't mean to use that. I did mean to use that. Good shout. Oh god. Okay. Node star. What? Why is this not working? Okay. What's wrong with this? I'm gonna ask ChatGPT just so I can get the syntax down because this is kind of weird. Probably not fucking logged in. Bruh. Don't show me the solution. I'm not looking at that. Not looking at that. Looking at this error. Give me what's wrong. You're right. No stars of your new node. There's a pointer string is new to allocate. Right. Okay. Yeah. So I just needed a little syntax help. Is all. Node star new. So node. So pointer to new head. New node. Okay, bang. So it compiles. And okay. Astrovan. Okay, hey, this is kind of cool. Okay, I kind of like this. So here's what we're gonna do. We gotta okay, so I guess we gotta traverse the original list, right? Here together. Oh. Yes, okay, this could be an issue. Just because. Okay. Let's think about this one. Chat. So, potential issues I'm seeing is, right, so you traverse across the list, right? Okay, well, you could do it where you traverse across the list twice. Probably not the best runtime, but so say you traverse across this original list, right, until you hit null. So this first traversal, right, you make all the new nodes for this new thing, this new list that we're making. Then in that you initialize or you set the value and the next, right? Okay. And then when you come back through it, you set random because, for example, if you're on 7, or that's a bad example, if you're making this one, you can't set random because you haven't made this node yet on the list. So you need to go through twice at least. We're all here together. Okay, so I guess let's just current node equals head. Well, current node does not equal the null pointer. So now we're traversing this. Now we're traversing this bitch. So this is just create the new linked list. Okay, so we just want to all that, and then current node equals current node next. Right? Yep. Okay, cool. So now we iterate through this. Iterate through this, John. Okay, so we also want to current node equals head. So on the current node, right? Then we go to the next node, but then we want to set the previous node equals null equals the null pointer, right? And then after this current node, we want to set current node to current node next, but we want to set the previous node to the current node. And these are also going to be pointers to nodes. Alrighty. Let's see. So now what we want to do is as long as the previous node, actually no, we already copied this, so we can start current node equals head next. Right, we already copied this, John. This equals head. Okay. So we're on the next node. Okay. So, and this doesn't account for the 0 case, but I'll go back and account for that. Actually, no, this will work. So now we want to make a new node like this. New node equals new node. We want to do the current node. Well, so that's the current node's value. So this new node is now the previous node. Previous node's next, right? The next value points to this new node. Okay. And then, yeah, and I assume this should work. Okay, let's just see what this says. It's still haven't set the random, but it should be output. Next pointer of node. So what? Event. New node, previous node equals, oh, right. Previous node should be the new head, right? Yes. Good catch, Nick. Okay, output next pointer of node with label 13 from original list was modified. Well, current node star current node equals head dot start or head dot next, right? Because we start on 2. Previous node equals the new head, right? Node equals new node. New node equals new node. Setting the current node. Yep, in the original list value. Previous node next equals this new node, right? Previous node does not equal current node. Previous node equals this new node. Current node equals this. Okay, I think that was the issue. Yeah. Yes. It was the issue. Bang. Okay. So now we have 7, 13, 11, 10, 1. Okay. Good. 1, 2. This is 3. Okay. So we're getting the values down. Okay, now we just need to set the randoms down. And how do you do this? Without, because I could make an array to help store them. Oh, I guess I could also just do this. If current node, let's just do the null thing right here. Current node random. Actually, I don't even have to do that because it's already set at null. It's already set at null. Okay. Jesus, more an astrovan. Okay, see. Oh, shit. Okay. So I need to somehow in this new list here store information about what node, like the equivalent node. How do I store equivalent nodes? Jesus was astrovan. It's a value, it has a next, and has a random. How would I do this? I could make. I could have a map. Okay, but that takes up more space. But let's just see if I can do it like that way, because I need a way to correlate the new list and the previous list. I have a map, and it maps. This map maps the old nodes to the new node, the address of the old of the original node to the new node, right? So that way I can just look up the map. Yes, okay. I think that would work. So basically the map has a key, which is the old node address, and the value, which is the new node's address. So basically when you're iterating through this, the current, if you find the address, so right, you got, let's say, this node, you got this node here, and then the address of this node is the key, and then the value is the address of the equivalent 7. So then of the key, you do key arrow random, that points to null. You do key arrow new. Yes, okay, that would work. That would work. That's O of n space. So it's not constant space, but it's linear space. But I don't see, at least off the bat, another way to make this work. Unless you count. No, because it could point to anywhere. You need, I don't know. Okay. C++, how to make an unordered map. I don't like doing all these new imports. Like Loki may have to include unordered map. Okay, how do I make it? Okay, this is just, I'm just putting this here so it's an example on how to do this. Unordered map. Okay, so this is going to be node star, and this will also be a node pointer to a node. Node correlations. Okay. I actually am going to want to put this above this while loop because I'm going to fill it up in this while loop. Okay, so now I have the first, let's put the first one in here. Node correlations. Node correlations. Head equals where is it? New head. Okay, does this run? Does this even run? It does run. Okay, we're J Chalon. Okay, now for every subsequent node here, we gotta do this line. So we add it to this map. Node correlations of the current node is set to the new node. Okay. Now you can come down here and go through, and again, we're just going to iterate through the list again. Update the random variable. current node equals head. I don't need any of this. Okay. So for the head, we want to get in the map, we want to find what the random thing is. So if you do node correlations, this, bang, bang, and we point this to random, this gets the random. This gets the random node, right? Okay, this gets the random node, the new random node, but current original node and current new node equals new head. Okay. So then let me set this up. Current new node. Current new node. Okay. So to get the corresponding, I don't care about inserting anymore, access element, this is, okay, so to get the corresponding node is node correlations, current original node. So this gets the new node. This returns the new node. Equals corresponding new node. Okay. Okay, I see. I just had to draw it out a little bit. So what we want to do here is have our current new nodes, current new node random. We want this to equal the node correlations of the current original node of, no, not the current original node. We want it to equal this current new node random equals current original node, and this will point. No, yes, okay. Current original node random. There we go. Okay, this should work. All right, and again, Python to C++. There's a reason they teach you C++ first, or they should. Error expected after. Check. Copy that. Bang, we're so back. Okay. 3 out of 19. Okay. Member access with a null pointer. Okay, so yeah, we gotta account for this node. I guess we can just go like if head equals the null pointer, then return null pointer. Take care of that 0 case real quick. Bang. Oof, not a very good memory, but great runtime. Okay, how could I have made this better on memory? Does this use any? Doesn't use a map at all. How could I do this without a map? Oh, this uses a map. What if I? Does this do anything? It changes my runtime? What? So if I have this in here, so if I include the unordered map, my runtime, oh, it's still the same. Okay, fuck, that's weird. Damn, I thought I had a good runtime. Oh, so do whatever. Okay, memory. How can I do this without using maps? Node. Copy random list. Well, temp does not equal null. Yep. New node next equals temp.next. Temp.next equals new node. That's whack. Explain how to do this with. I'm asking ChatGPT. Modify the list in place. Then restore the original list at the end. Interweave the copy nodes with the original nodes. Create a new copy node. Insert it right after the original. So A, B, C, null pointer. A star, B star, C star, null pointer. Ah, I see. Assign random pointers for the copy node. Since each copy node follows its original, the original random next. It's original or random. I see. Okay. Modified in place. Okay, so I guess with these O of 1 problems, modifying in place is usually the way to go. I just text. Okay, is there a way to, yeah, okay. I'm gonna do this. Like this. this an O or 0? O1 space. Constant space. Oh my god, this is only one question. I got heavy questions. I gotta grind. Fuck. Alright. Well, I guess we could just do this. Copy this. If n equals null pointer, return the null pointer. Get the 0 case out the way with right quick. Now I'm going to do the format where it's like A to B to C to null gets turned into A to B star or B prime C prime, and then null pointer. Okay. So I'll construct, I'll go from the original list to this list, and then I will decouple the lists. That's going to be the plan of attack here. Okay. So, the node star temp equals head. Yes. Node star. Okay. While temp does not equal the null pointer. All right, we're just going to iterate through. We're going to change this original list into that list, and then we're going to go from this list, decouple them. Okay, bang, let's do it. Okay, let's get after it. Go over object-oriented design questions too. There's so much shit I need to study. Jesus Christ, Astrovan. Temp does not equal null pointer. Temp does not equal the null pointer. How do I make this? Node star. Node star. New node equals new node. I'll go temp val. All right, this is just simple copy. Simply copying it over. So now we have the new node. What is next? Next is just a pointer, a node star pointer. node star temp next equals new node, no, equals temp next. I'm going to change this temp to cur. No, I'm going to keep it as temp. No star new node. Yep. No star temp next equals this.
Did you eat? Did you eat anything? Okay.
Then what we want to do is we want to set the I'm going to change this to cur. Just easier for me to see. Then we want to set the current next equal to the new node and new node next equal to cur next. Okay, yes, so cur next equals new node next equals cur next, which is the original one. Okay, cool. And then cur equals cur next. And then we just move on. But this doesn't update the random. I don't think we can update the random yet. Then we're going to have to cycle through the list one more time. Okay, so this creates the list. All right, we're back. Was able to update the random pointers by just doing this logic. The new node, right, is the cur next. New node random equals the cur random next. Decoupling the list, now it involves new node. So I got the new node, the current next, right? So the next, so now I need to update this equals new node next, right? Otherwise known as current node next. So now current next is updated. Now I just need to update new node next equals new node next equals new node next. Well, I could just do this. Current node, new node is current node next. Current next equals new node next. New node next equals current node next. Let's do this. Okay. Oh shit, but how do I progress through this list? So current next equals new node next, right? So let's say here, new node, so this is current, right? New node is current on next. So this is current, this is next. Current dot next equals new node next. Okay, so this is set. New node dot next equals current node dot next. No. Current node next. Yeah. Okay. And then I want to set the current on equal to next, current on next, right? And then that's return shit, I gotta do this. Forgot to do this new head thing. And then node current, head that next, and then next equals new head. No. Yeah, okay. Head next equals new head, and then current equals head next. New head next equals current. Does this work? Because I didn't return anything. '83, new node. Let's start a new node. Oh, fuck. What am I doing here? What am I doing here? Node star current. I'll just copy this up here. Why don't I just copy this up here? This is all I'm doing. Node star, new head, go to new node. Head not val. Node cur next. Goes. Next. Head next equals new head. New head next equals head next. Yeah, okay. Node new head equals new node. Node star head next. Equals head next. Next equals new head. New head next equals head next. Yeah, okay, cool. This should work. '71. Head. I don't need this. Here we go. Ugh, what is wrong? Member access with a null pointer of type node. Line 86. Update the random pointer. Because I don't check for the random. Update random pointer. I could be like if cur random equals null pointer. I just check if it does not equal null pointer, then do this. What? Okay, I see what's wrong here because I didn't add this. This should be on the outside. Line 102, I'll probably do the same thing. Decouple the list. Skip the temporary node, yep. Some error. Member access within null pointer of type. Member access within null pointer. Okay, so new node next. It goes current.next, right? So what if it's on the last one? New node next. Current next. Current next equals new node next, right? But I don't check if it's at the end of the list. Okay. Well, I probably want to check that. If new node next equals null pointer, then I'm at the end of the list. Then what do I want to do? Else, just do the rest of this. If it's the end of the list, I want to set cur next. I've got the new node. I want to set cur next to null pointer. Cur next equal to the null pointer. And new node next. And new node next is already equal to null pointer. Else cur equals cur next. Cur next. I could just set I guess I gotta set Current equals head, right? Yeah. Yeah, I'm making the list wrong. I think I'm making the list wrong. So circle 2 No, next equals cur next. No. Oh, okay. Pointer for the new nodes. Oh my god. Didn't. To decouple the list. Current equals head. Next. Right, because I didn't freaking update the head. Classic. It's the freaking details, man. It's the details. Current equals head next. Okay. Now I can go like head next equals the current one, right? And the new head next equals current next. Bang, this should work. It doesn't work. It doesn't work. It doesn't work. Why? I just had a realization. I go like this. Node star cur equals head, right? And then just go from here, right? Update the right factors for the new nodes. I think you still need this. I'll just do if cur.random, cur random. Well, cur, so this is a truthy value. If not head, well, cur, update random pointer for the new nodes. Yep. Skip to temporary node. Check that. Decouple the list. Okay, here we go. Now I can just go like this. All I need to do is cur equals node star new head equals cur equals all right, I'm just gonna new node equals cur next. Okay, so I new node. So now cur next. If new node next, if new node next, all right, if it's legit, it's got shit after it, then cur next equals new node next and new node next equals new node, next, else cur next equals the null pointer. And new node next already equals null pointer. Bro, what the fuck is wrong with this? Is cur next? Where is this happening? Fucking hate this. I hate Leetcode. Oh my goodness. Where do I not advance it? Advance the cur pointer. Gosh. Golly. Yep, well, that took a lot longer than it should have. But much better in memory. Okay, bang. Oh, okay. Fuck. All right, well, that problem was fun. Fucking took however long reorganizing it. So all these little fucking issues. Yeah, I gotta do better on that. All right, anyways, on to the next one. Given a string S, rearrange the characters of S so that any two adjacent characters are not the same. Return any possible range of S, or return blank if not possible. Okay. So, as you got a string, right? So return, given a string, range of characters from any two adjacent characters not the same. So I guess if you were going to try and detect this, you'd be like, you keep track of the previous character, and you'd see if the current character is the same. The current character is the same as the previous character. Yeah, okay. I think I see how to do this. Start here. Oh, you see previous characters. Same. Move like that. Then you move back here. And then you check it again with before. That creates issues if it's at the end of the list. Yeah, okay, so how I'm thinking about this is you iterate, you go through this list, right? You see the first one. There's nothing before, so you're fine. You go to the next one. You see that it's the same as that one. So then what do you do here? You move this character. You switch it here. And you keep going until, oh, so you see they're the same, right? So you get another pointer and you keep going until you find one that's different. And you swap them. Well, you could do this so, because at the end of the word is you always start looking at the beginning of the word, right? So you see this wrong. Oh, so you start looking at the beginning. Nope. 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 Yes. You move it there in place. If you want to check, if it's less than it, it's less than the current position. Let me check. I need to draw some more examples. Oh, that's not good. So start at the beginning. Nope, that's different. You get here, and then you check left and right. Oh, it's the same. No good. Check this. Nope. Check left. No good. Check here. Check left and right. No good. You get here. No good. And you're back here. Okay, so this doesn't work. It does work, actually. Drop the A and the D. Oh my god, this fucking sucks, dude. I fucking hate Leetcode. And you check the one in front of it. Nope. Nope. a DNA swap. That's the only way this works. So, check. It's good. 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 Bang. Oh, no good. No good. No good. So then you look for shit to change. You only check before. Say your prayers and all that. Swamp one's good. This one's interesting. No. To move the middle one. I don't need to swap. Well, yeah, I don't need to swap. I just need to find a spot to put it. I'm thinking about swapping. I'm thinking about swapping two letters. You don't have to swap them. Ugh, the insertion is gonna suck. So I love you till my bones. I love you. don't fucking know. Let's just start coding it. I'll see if it fucking works, bro. Shit is confusing. What's Adderall to nothing, bro. Yes, that's not length equals 1. Return S. Previous. The char previous. S at position 0. Bang, bang. For C and I equals 0, I less. And N equals S dot length. I is less than N. Plus I equals 1, right? We're all setting it. Oh, okay, what if we check forward and backwards? Oh, this is bad. And this one here. No. Bad. No. Oh, shit. Starts from here. And it's not here. That's not the order. Yeah. To N minus 1. I don't want to do the last one. Okay. previous char equals s at I minus 1. Current char equals s at I, of course. And next char equals s at I plus 1. And all these are chars. Okay. So if current char doesn't match the last one or the next one, then we're good. We just move on. But if it does, if current char equals previous char or current char equals next char, then we gotta loop through again. Gotta loop through again to find a place to put it. And j equals 0. J is less than n. J plus plus. J equals 0, right? Which is the first one. Else if j equals n minus 1, else, okay, here we go. If j equals 0,
Burger's ready, Nick.
all right. All right. I gotta end this stream because I gotta eat. But I'll be back. We'll finish this problem. I will solve it.